This vodcast is on oxidative phosphorylation and the electron transport chain, which is step 3 of cellular respiration. We're going to start with a little review, as we have done in the other vodcasts, to remind you of where we've been and where we're going. We discussed step 1 and step 2 already, glycolysis in the citric acid cycle, and hopefully you recall that we are at the point where we've made a bunch of hydrogen ion carriers, the NADH and the FADH2, but we haven't made very much ATP. Okay, there's a little bit of ATP made in glycolysis, a little bit of ATP made in the citric acid cycle, but really we haven't gotten to the whole goal of this whole process of cellular respiration, which is to make a bunch of ATP. So, on to oxidative phosphorylation and the electric transport chain, or step 3. And in this one, remember, the main job is finally to make this ATP. We're going to use all these hydrogen ion carriers that we created in step 1 and step 2, and we're going to use those to actually make more ATP than we have in either of the other steps. Again, a quick little reminder of the mitochondria and what it looks like, because we're going to go into a new area of the mitochondria today. We've got the matrix in the middle in blue. The outer membrane is in that darker brown color, and the inner membrane is the folded membrane. And the area we're going to be looking at today is right in here between the brown outer membrane and the thinner folded outer membrane and the thinner folded inner membrane, and we call that the intermembrane space. Okay, so we're going to look at just a little section of that intermembrane space, and we're just going to take that little section, so we take like from here to here, and we're going to look at it like this. Okay, so here's the inner membrane. Okay, this is that folded membrane. This down here is going to be the matrix. Okay, so it's like this blue area in here. Okay, so we've got the inner membrane that stretches across. We've got the matrix. And then right here is going to be that inner membrane space. So that green area that I highlighted earlier. So on our last step here, this oxidative phosphorylation, it's going to take place across this inner membrane. Remember, that's what I shaded in here, the wavy membrane, so that on one side of it we're going to talk about that inner membrane space, and the other side of it is going to be the matrix. It happens along the whole inner membrane, of course, but we're just going to look at a little section of it. All right, on to your diagram. You should have a diagram of this already, hopefully ready to go. As we've done with the other steps, I'm going to talk through it and label these sections. This one is a little bit different because we're not going to look at so much as a chemical reaction, but a process that has steps to it. So first of all, oxidative phosphorylation. Okay, what does that mean? Oops. Oh man, getting way off here. There we go. What this actually means, phosphorylation right here, refers to making ATP, and oxidative means we're going to use oxygen to make that ATP. And you'll see in a little bit how that happens. Alright, so first we're going to start by filling in the boxes. As I said, this should look kind of familiar. This is our inner membrane. So INNER, and I'll abbreviate membrane. So this whole thing is that kind of brownish colored stuff. I'll make it red for our purposes here. Okay, that's that kind of wavy membrane in the mitochondria, that inner membrane, which means on one side of it, again, as I said, we have the matrix, which I colored blue in your other diagram, so I'm going to make that a little bit blue right now. And label that matrix. That's what this little box is for down here. Okay, and then the other side was that inner membrane space, which I made green. So I'll make it green now. And label it inter, not inner. Inter means between. Membrane space, because it's the space between the inner and the outer membrane. Right? So that kind of sets us up where we are again in relation to that other picture. Oh, this is supposed to be labeled in there. I just can't fit it in there. This itself is the kind of the area where things take place. Now we're going to go through the process of what actually happens here. So remember we had all those electron ion carriers that were hydrogen ion carriers that were made in glycolysis and in the citric acid cycle. So we had lots of NADH made in both, and then we had some FADH2s made in the citric acid cycle. Remember I said this is like a regular school bus, this is like a coach bus, and their job is just to shuttle the hydrogen ions around to where they're supposed to go. Well, this is where they're supposed to go. So the first thing they do is they drop off their hydrogen ions in this matrix area. Okay, so there's hydrogen ions that are loose. These are my H pluses, even though it's not writing very well. H plus, they drop off their hydrogen ions in the matrix, and then they go back to glycolysis in the citric acid cycle to get more hydrogen ions, so they can be reused over and over again. But the hydrogen ions are still there, so what happens to them? They actually get pumped across the membrane. Oops, H plus, that's supposed to be H plus, getting pumped across the membrane through active transport. All right, this is active transport because they're pumping it into this inner membrane space. So what happens over time, I'm just going to do this in a color. My hydrogen ions are going to be represented by yellows, okay? You can draw all sorts of hydrogen ion colors in here. What happens is over time we get a concentration of hydrogen ions that's really high in this inner membrane space. Okay, so this area right here has a high concentration of hydrogen ions compared to this side of the membrane in the matrix, which has a low concentration of hydrogen ions. And as you know, to move something from low to high concentration, you need active transport. So these pumps in the membrane, these ovals, are pumps or proteins in the membrane that allow those hydrogen ions to go through the membrane. Remember, ions can't go through the membrane without a channel or a pump to get through. So we build up this huge concentration of hydrogen ions on the inner membrane side, or the intermembrane space side of the inner membrane.